Hello, I wanted to make you a video to help you with today's lesson. So just a few warm-up questions. What are these angles called? They're across from each other. They are vertical angles, and vertical angles are congruent. Make sure you know that. How many triangles would be made with angle measurements of 100 degrees, 50 degrees, and 30? So as long as when you add up those degrees, you get 180. Then the answer is an infinite number of triangles. Infinite number of triangles. All right, or sometimes it'll just say more than one. Yep, so as long as those angle measurements are 180, you can make a little triangle, a tiny triangle, a itsy bitsy triangle, a medium triangle, a huge triangle. But if we're talking about side measurements like 3 inches, 4 inches, and 5 inches, that's set in stone. You can't change the size of 3 inches. So the answer would be exactly 1 based on the triangle inequality theorem. And then number 3, I already gave you the answer. Vertical angles are always congruent. Vertical angles and corresponding angles are always congruent. So today we're going to look at three-dimensional figures. So what's the difference between a prism and a pyramid? So here our picture shows us that prisms have 2 bases and a pyramid has 1 base. And whatever that base is, that's part of our name. So for example, the base is a hexagon. So pyramids, the other difference is that the sides of pyramids are triangles. And for prisms, the sides are always rectangles, right? So they have a few differences. So we're going to watch a video about slicing three-dimensional figures. So let me stop sharing for just a second and find my video. It's only a little over a minute. So you guys pay attention to this, please.
Shorts.
Slicing solid, three-dimensional figures results in different two-dimensional shapes, depending on how you slice them. If you cut through a cylinder with a geometric plane parallel to the cylinder's base, the two-dimensional cross-section is a circle. Any way you slice it, you can get two-dimensional shapes from three-dimensional figures. When you slice a cylinder from top to bottom that is perpendicular to its base, then look at the cross-section straight on. You get a rectangle. What happens when you slice a square pyramid? If you slice across the pyramid with your plane parallel to the pyramid's base, the cross-section is a square. If you slice with your plane perpendicular to the pyramid's base, the cross-section is a triangle. Remember, you're slicing a solid, three-dimensional figure with a geometric plane. You can slice in any direction. Just keep in mind that shapes can look different when you look at them from different angles. So orient the cross-section on the geometric plane. Slicing diagonally can produce different shapes, such as an ellipse or a trapezoid. Understanding the two-dimensional shapes that result from slicing solid, three-dimensional figures is important for geometry and ninjas.
All right, let me go back to, especially ninjas, everybody. All right, so let's go on to our next slide here. So I've already done those. Whoops. All right, so here we have 6 three-dimensional figures. So imagine if you have a cake, you baked a cake, it's a cylinder, right? If you slice into it, take a slice of that pizza out, well, the sides of that slice of cake is a rectangle, right? So every time you make a slice of a three-dimensional figure, you get a two-dimensional picture. So two-dimensional figures are squares and rectangles and circles and ellipses and trapezoids, so on and so forth. So if I'm holding anything in my hand, so here I have the rest of my sweet tea. So this is a cylinder, kind of. The sides aren't exactly straight down. But if I cut this glass parallel to its base, and if I open it and look at it, it's always going to be the shape of the base, which is a circle. So any cylinder, let me drink my tea here. Very sweet. Any cylinder, if you cut it parallel to its base, the two-dimensional figure is going to be a circle. However, if this was a cylinder and I cut it all the way down, and then I opened it and showed you the two-dimensional figure, it's going to be a rectangle. It's going to be a rectangle, okay? All right, so which of these, let me see the next question. Which of these is being cut parallel to its base? So this way. So which figures are being cut parallel to its base? This square base pyramid is, this rectangular prism is, this 1, 2, 3, 4, this pentagonal prism is, and this cylinder is all being cut parallel to its base. Now, perpendicular, so think about perpendicular lines. When they meet, they make 90-degree angles. So if I say I'm cutting something perpendicular to its base, that means I'm cutting it vertically. So this square base pyramid, if I open that and looked at the flat surface of that square base pyramid, I would see a triangle. And this one, I would see a rectangle. All righty. So look at another square base pyramid. If I cut it not in the center of the point, but down here on the side, straight down. It's not pen working yet. So can you see what it would make? So what figure looks like this? What is that? What is that figure? That's a trapezoid, right? Trapezoid. Here, you can kind of see the triangle it would make if you go straight down, cut it straight down perpendicular to its base. And then, of course, if you cut it parallel to its base, it's always going to give you this shape of the base, which in this situation is a square, okay? All right, so we answered that question. So hopefully you guys understand. Now, if I sliced a cylinder, well, I'll get to that question in just a second. All right, so now that moves us on to finding the area of figures so that eventually we can find the surface area of three-dimensional figures and then the volume of three-dimensional figures. So just to review from 6th grade, when you are asked to find the area of a triangle, you find the product of the base times the height, and then you divide it by 2, right? Well, a height of a triangle can only be found by creating a right angle, because diagonal lines are always going to be a little bit longer than perpendicular lines, straight down, straight vertical lines. So in order to find the height, you always have to look for a right angle. So this right triangle, the height really is 7. But this triangle that does not have a 90-degree angle, they're always going to give you a 90-degree angle to give you what the true height is. So on the first one, if we multiply 7 times 6, we get 42, but always you half it. You half the base times the height for the area of a triangle. So the area of this first one will be 21 inches squared. 7 inches times 6 inches is 42 squared inches, divided by 2 is 21 squared inches. And then 14 times 8.5 is 119 divided by 2. That would be 59.5 inches squared, 59.2 inches squared. All right, now a trapezoid, last year in 6th grade, you guys, when you dealt with trapezoids, you guys basically divided it into 2 triangles at the end, 1 triangle, 2 triangles, and then a rectangle in the middle. Well, we're not doing that anymore. So we're going to use the area formula for trapezoids. So trapezoids always have 2 bases, and the bases are those 2 parallel lines. So look at this trapezoid. This line and this line are parallel. So that means the bases is 12 and 7. So we're going to add 12 plus 7, and then we half it. And then we multiply the sum of the bases, half of the sum of the bases, times the height. So once again, we're looking for a right angle. So if they told us that this side was 4 and this side was 4, Well, we could use that to find the perimeter, but not to find the area because we have to have that 90-degree angle right there. So we would multiply this answer by 3. So I'm going to add in my calculator. 12 plus 7 equals divided by 2. And now I'm going to multiply that answer times 3. And my answer is 28.5. So you guys do that and make sure you can get the same answers as I did. Okay. All right, let's look at the next one. Let me get rid of all the stuff. All right, now rectangles, you know, it's my dog. To find the area of rectangles, you just multiply the base times the height or length times width. And we get 8 centimeters times 3 centimeters is 24 centimeters squared. And that was it. So we need to know all of that stuff in order to find the surface area of 3-dimensional figures. So our first one here is a prism. So prisms, of course, have 6 sides. So I always give myself a little key over here. I say top and bottom, because they're the same dimensions. Side and side, those are the same dimensions, and front and back. So top and bottom, I'm talking about this dimension times this dimension. So 4 by 5, so 4 times 5 is 20. I have a top and bottom, that's 20. And then our sides, if you'll just kind of trace it, it'll remind you what those dimensions are. The side is 10 meters high by 5 meters. So both sides is 50 meters squared. And then the front and the back. So the front is a 10 by 4, right? 10 by 4. So I have 2 of those, front and back. And then finally, I add all 6 of my sides together. And I get 40 plus 100 plus 80. I get an area, surface area of 220 meters squared. Remember, area is always squared. Now let's look at this triangular prism. This is the triangle, right? So we're looking for the area of the base. So the area of the base, which is a triangle. So remember, the area of a triangle is half the base times the height. Also, you could write it base times height divided by 2. And remember that height, we always have to have a right angle. So this triangle right here has a height of 4. So even though this side length is 5, that's not the height of the triangle. The height of the triangle is 4 because it's perpendicular to the base of 6. So I'm going to do 6 times 4, which is 24, but then we have to half it, right? Because it's a triangle. So the 2 triangles are 12 each. So we have 2 bases, they're 12 each. And then we have 3 rectangular sides. 3 rectangular sides. Sometimes 2 of them are the same dimensions, and sometimes, well, I guess they always have to be. 2 of them have to be the same. So let's look at this side over here. We have an 8 by 5, and the back is also 8 by 5. So 2 of these are 40. But then on the bottom, we have an 8 by 6 on the bottom. Can you imagine? 8 by 6 is 48. And we're done because the triangular prism only has 5 sides. So I'm going to add 12 and 12 plus 40 is 80 plus 48. Uh-oh, I messed up. 24 plus 80 plus 48 is 152 centimeters squared. 152 centimeters squared. And that is the surface area of my triangular prism. Let's look at the next one. We had another triangular prism. I want you guys to pause this video and solve it for yourself, and then turn the video back on and check your answer. All right, so let's do our 2 triangles and 3 rectangles. Well, that's not a rectangle, but you pretend it is. All right, so my triangles at the end are an 8 by 3. So 8 times 3 is 24, but then you half it. So we get 12 and 12 again, just like the top one, but the numbers are different. And then our sides are 5 by 10. 5 by 10. Both of these sides are 5 by 10. So 50 and 50. And then the bottom of it is 10 by 8. 10 by 8 is 80. So what did you guys get? Let's see. Did you get 24 plus 180 is 204. Did you guys get 204 centimeters squared? I hope you did. All right, what about a cube, you guys? A cube, good thing about all those sides is they're all equal, right? So each side of this cube is a 7 by 7. So each side has an area of 49 feet squared, and a cube has 6 sides. So what'd you guys get? 49 times 6? Hopefully you got 294 feet squared. All right, one more slide. Now volume is the base times the height times the length, or length times width times height. And then when you have a triangular prism, you always want to find the area of the base. And then you're going to multiply the area of the base times the height. So the area of the base, so think about this as a triangle. So you're going to find the area of the base. So this is going to be 24 times 7 divided by 2, right? That's the area of the base. And then you multiply it by the height of the prism. But when you have cubes and cylinders, I mean, not cylinders, but rectangular prisms, it's easy because you're multiplying 3 dimensions together. So that cube is simply 7 times 7 times 7. So that one's 343. Feet times feet times feet is feet cubed. The prism in the center is 5 times 3 times 2. So that one's 30 centimeters cubed. You guys try the rest of these, okay? And then turn on the video and check your answers. So then our triangular prism, we're going to multiply 24 times 7. And then since it's a triangle, we divide it by 2. So the base, the area of the base is 84. And then I'm multiply 84 times the height of the prism, which is 22. So the area is 1,848 meters cubed. And then let's see what this one says. An aquarium holds this much water, so that means its volume. The area of the base, so this area of the base would be 24 times 7 divided by 2. So they've already done that part. They've already divided, or excuse me, multiplied the area of the base. And now the question is, what's the height? So the volume would be 3,024 times equals the area of the base, the capital B, is 168 times the height. To find the height, we want to get H by itself. So right now, H is being multiplied by 168. So we're going to divide both sides of the equal sign by 168. So 168 divided by 168 is 1, and 1 times H is H, equals 3024 divided by 168, and the answer is the height is 18 inches. Height's 18 inches. All right, the second one says a pool holds 2,250 cubic feet of water. So they're giving us the length and the width. They want us to find the height. So the area of the base will be 30 times 50. So we're going to multiply 15 times I guess we could say the height of the pool. So now we're going to multiply together 30 times 15, and we get 450. And then we want to solve for H by once again dividing both sides by 450. So that goes away. So H is, what'd you guys get? 2250 divided by 450 is 5. The pool is 5 feet deep. All right, you guys, I hope that helped. So you guys still, even though I made you this video, you need to read the section for 3D figures, do all the practice problems, make yourself some notes, watch a video if there is one, and then take the little formative assessment at the end. All right, I will see you guys tomorrow for our Zoom meeting. Have a great day.